Discussion after precision and accuracy. Let's talk about how to deal with scientific notation. So how can we identify numbers and how to convert those significant values through scientific notation? So it's very important for us guys, when and how to add, subtract, multiply, or divide numbers according to scientific notation process. But for this time being, okay, let us start from the basic parts to complex one. So say for example, okay, we used to recognize the scientific notation according to how we count, how we read numbers. From 0 to 10 values, from 0 to 1,100, okay, until millions. So when using scientific notation, remember, there are two kinds of exponents. One, positive, two, negative. Okay? Have you guys learned this one before? Yes? When was the last time you learned how to solve problems through scientific notation? You still remember? For positive exponent, when you notice guys, we have three significant values, 3 digits, right? Why 3 digits? 2, 3, and 5 are 3 digits. Okay, 3 important figures. What is a times 10? Okay, it is a power or base 10. Raised to the exponent. Where is the exponent here? Okay. Where is the exponent? Do you know? The exponent value is this one. Written at the top of base 10. What is the integer here? Positive or negative? Is it positive or negative? Positive, exactly. When it comes to negative exponent, remember this. It might be also written like this. Okay? 3.97 times 10 raised to negative 7. Now the question there, how to convert this scientific notation into a whole figure of numbers. Okay. When changing scientific notation, standard notation, the exponent tells you if you should move the decimal point to the left or to the right. Okay? Is it positive? When we say the exponent is positive, we shall be moved. Okay? Where are we going to move these things? So, let's find out. With a positive exponent, we should move the decimal point to where? To the right. Okay? So, in what way? So, for example, you will be given this one. Okay? 4.08 times 10 raised to exponent of positive 3. Do you know what is number 10 there? Okay? This is the common representation of power of 10. Okay? Especially if the numbers are considered as largest number. Okay? So to simplify into a smaller or whole digit value, that is the purpose. Okay? So therefore, to continue with this one, no? Y it turns out 4.08. Okay? So it goes like that. Okay? So therefore, 1, 2, 3. You understand, guys? Okay? Don't blink your eyes because we have to continue this one, no? With the other complex part. So therefore, the whole number now, no? You have to convert this one, no? By following the positive exponent. Where are we going to move the decimal points? Huh? We move the decimal point to where? Okay, going to the right. Okay? So instead of writing 4.08, so we have to follow this one. Since it is positive 3, 1, 2, 3. Okay, so what will happen to the gap? Add more 0. So since we follow to 1, 2, 3. So add more 0. That will become 4080. So don't forget to fill in the zeros if it's necessary. Okay? Because we need to follow the value from scientific notation to the significant whole number value. So what if it's negative exponent? Where should we move the decimal point? Okay? So if it's negative exponent, like for example here, 4.08 times 10 to negative 3. Okay? Our exponent is negative 3, right? So we have to rely what is being asked. No? So follow this way. Since the original value was 4.08, right? Where shall we move? Okay, where are we going to move the decimal point? Okay, 1, 2, 3. Understand? Easy, no? Very easy. Okay, good job. So, again, don't forget to fill in the zeros. Remember that we are learning already about the significant digits. When it comes to non-zero digits and zero digits. Right? So, the easy way to remember, if an exponent is positive, the number gets larger. So, move the decimal point to where? Going to the right. Okay. If an exponent is negative, okay, the number gets smaller. No? So move the decimal point to where? To the left corner. You should learn which one is the right hand side, which one also the left hand side. Okay? The exponent also tells how many spaces to move. No? The decimal point, 4.08 times 10 raised to the power or raised to the exponent of 3. Okay? 1, 2, 3. So in this problem, the exponent is positive 3. So the decimal moved 3 spaces to where? To the right. Understand? Please remember. The exponent also tells how many spaces to move the decimal point if in this condition will be negative exponent. 1, 2, 3. Correct? 0, 0, 4, 0, 8. Then, that's it. So that will be 0.00408. Okay? As its significant value. Okay. In this problem, the exponent is negative 3. So the decimal moves 3 spaces to the left. Right? Okay. Do you know how to do this one? Okay, everybody, do it. Get your notebook now. Okay, so I hope everybody just only few basic examples and try to extend those given problems, okay, projected in this slideshow presentation. Okay, use your notebook and try to change the following numbers from scientific notation to standard notation. Is there any question, guys? Okay, none so far. Please continue.